Hello guys, welcome back. And now this is our series of data visualization and graphs, and this is our fourth video on types of graph. So let's start the video. So now first type in this video is a spline chart. Now the spline chart is a type of line chart where the data points are joined together by a smooth curve, and they can be easily drawn, as well as the main advantage of this spline chart is it can visualize the quadratic functions and polynomials. So guys, in the line chart, the x-axis and y-axis or the representation was similar, but the difference was just the points which we have plot on the graph are joined by the straight line in the linear graph or line chart, right? But in spline we are joining these points by using a smooth curve, and due to that use of smooth curve we can plot or we can visualize the quadratic functions just like the ellipse, parabola, hyperbola. So we cannot draw them by using the straight line, so we can plot the equation for the quadratic functions like the hyperbolic functions or ellipsoid function, etc., or the polynomial functions. So it is the similar like line, just the line is represented or replaced by the smooth curve. Now next type is the waterfall chart. Now the waterfall charts are used to visually illustrate how a starting value of something becomes the final value through a series of intermediate additions and subtractions. The best example is, so we can plot the amount of the monthly initial balance in an account to the balance in the account at the end of month, and we can illustrate or we can visualize this by using the waterfall chart, because at the beginning of month we have some X amount in our account, and after at the end of month, after some additions and subtractions, means the additions means be some income will be considered as additions and the expenses will be considered as the subtractions, and by doing that in the whole month, at the end there is something, the amount is something different which is in our account, right? So we will see one example. Now the waterfall chart, that it illustrates the cumulative effect, means step by step effect of sequential or categorical positive and negative values applied to the starting value of the plot, as well as because they often, means the blocks or the bars in the waterfall chart often appear as the bars are floating throughout the graph, means these bars are floating throughout the graph. Waterfall charts are sometimes referred as floating bricks or Mario chart. Now this is one of the example of the waterfall chart, and we will see how it works or how to read the waterfall chart. Now the graph shows the total profit or total profit of a company, say the total profit in US dollars for 2008. Now the x-axis shows the different categories. These are the product revenue, services revenue, fixed cost, variable cost, and total. That is, this is our profit. And say this y-axis is showing the different amounts, that is the 140k to 280k up to 700k, right? So first this is our base or starting point, that is the product revenue. So it is starting from 0. So the product revenue is 420k, so it is starting from 0 to 420, means our total product revenue is $420k dollars. Then is service revenue. Now the service revenue will not start from base or start from 0. It will start from 420, because these two we have to add these two. That's why at the top of the product revenue there is a dotted line, and the services revenue starts from that dotted line, right? And that is 220k. But the total revenue will be 210 plus 420k, right? So it will be something about 630, so above 560. So it will, at here it will stop. After that, these are the cost, means these are the subtractions. These two were the additions and these two are subtractions. That's why this first, that is fixed cost, that is starting from the end of service, addition of product and services revenue, right? So it is starting from this upper dotted line and it is moving downwards, and it is written as minus 170k. It means it is subtracting from the total of these two. Again, there is one more variable, that is variable cost. So that will again minus 140k, means here while they are adding or in the revenue, the total was something 630k. So here from the 630 we will minus 170 and minus 140. So this will be approximately 310k. So 560 minus 310, we will get the 320. This is our total profit. So in this manner we have to plot the waterfall chart, and from that waterfall chart we can interpret that this is our say revenue or additions, and these are our cost or subtraction, and this is our remainder, or say we can say the actual profit, right? So this was for the waterfall chart. Now next type of chart is a heat map chart. Now in heat map chart, or generally it is called as just heat map, is a two-dimensional visual representation of data where values are encoded in colors or range of shades, delivering a convenient, insightful view of information. And it is mostly used to plot large and complex data, right? Now the heat map means heat map chart, or in short it is called as just heat map. So it is a visual representation where the values are encoded in colors. Basically the colors are represented in the form of range of shades, right? So the higher or lower value says the lighter or darker color, and the other side will be the opposite, that if the higher value is representing darker, then the lower value will represent the lighter shade of any color, right? So we will see the example of heat map. Now this is the first type, that is correlation heat map. So each cell in table, now this is the table, and the table is showing the correlation of each variable with the every other variable, okay? So each cell in the table can contain a numerical or logical value that determines the cell color based on a given color palette, and each cell shows the correlation of variable with the every other cell, right? Now this is the color palette which shows the value of correlation, means the highest number is 1 and the least is minus 0.6, and depending upon the correlation the cell will have color. So now we can see that the L stat and the L stat, so the relation of L stat with L stat will be always 1. That's why all the diagonal values are colored in the color yellow, that is which is representing the correlation value 1. And now here the L stat and the M made V, right? L stat and made V are having the negative correlation, that is least correlation minus 0.74, that is the less than minus 0.6. That's why it is shown in the darker color. So the values defined here are the correlation of each variable with every other variable, and this color given to that cell, that is that logical value determines the cell color, and this cell color is based on this color palette, right? So from observing this palette and just observing this table, we can find out where the correlation is strong and where the correlation is weak, right? So again there is a next type, that is heat map using a map, means the heat map using the geographical map, means we can print or we can show or visualize the values in the database with using the map by the again using a color palette, right? Like here it is written a little to a lot, right? So heat map can also be used to show different values of a particular variable on a geographical map. Specifically, the meteorological departments use them to show the weather warnings, means where there will be the higher rain, where there will be the less rain, or the higher wind, lower winds, or say the warnings for the cyclones. The meteorological departments use this heat map with a geographical map. Now this map shows the map of USA, and here is the palette that is showing the values from a little to a lot. Means if the color is faint, then the specific that certain value of that certain variable is less in that region, and when as the color gets darker and darker, the value gets increased, or the value of that specific variable gets increased, right? There, as mentioned here, this is the darkest color, so the value is higher in this region, right? So by using this technique, we can use the more complex or more say we can higher sized data. Okay, now next type is the box plot. Now as a data analyst or as a data scientist, this box plot is the important part for the finding out the insights, or basically this part is important for the pre-processing of any data, right? So we will see in detail that is what is box plot and how to use it, why to use it. So now the box plot is a standardized way of displaying the data set based on a 5-number summary. That 5-number summary is a statistical summary or statistical calculations. That 5-number summary means that it includes 5 numbers. First is the minimum, second the maximum, third is the sample median, fourth is the first quartile, and fifth is the third quartile. So by combining these 5 numbers, it becomes the 5-number summary. And this box plot explains the data set, or this box plot explains the gives the statistically explanation of the data set depending on this 5-number summary. So the minimum value will be the lowest data point excluding any outliers. We will see what are the outliers. Then first quartile is also known as lower quartile, is the median for the lower half of the data set, means the values below mean is called as lower half, and first quartile is the median for that. Then median is the middle value of the data set. Then third quartile is the also known as upper quartile, and it is the median of upper half of the data set, and maximum will be the largest data point excluding any outliers, right? So here is the construction of the box plot. So the box plot is a construction of 2 parts, a box and a set of whiskers. Now this is a box from Q1 to Q3. This part is called as box, and these 2 lines, that is from this green line minimum to this Q1, and from Q3 to max, these are the 2 whiskers. Now any box plot will have maximum 2 whiskers. Sometimes it has 1 whisker, sometimes it has 2 whiskers. So it is univariate and bivariate, it is called as then in detail. Now the whisker shows the minimum and maximum values, while the end of the box shows the lower and upper quartiles, and the line in between that box is called as median. Now this median is not necessarily it is at center, it can be shifted towards left or right, and we can say it can be shifted towards upper side or lower side. Now this is called as a horizontal box plot, and this is a vertical box plot, right? So most of the data, if there are no outliers, then 100% data will be in between minimum and maximum, but if there are outliers, then these will be shown outside of these whiskers. Now we will see it how it's shown. Now this is the second type of box plot, that is box plot with outliers, right? So, and first we will see what is outlier. So an outlier is an observation that is numerically far distant from the rest of the data. And when reviewing a box plot, an outlier is defined as a data point that is located outside the whiskers of that box plot. Means, first of all, the outlier means that a specific value which is a much larger or which is having a very large difference in between it and the remaining all values, right? Then it is called as outlier, right? So this plot shows a churn model for say any variable. There are the two types. There will be two outcomes of churn. Obviously there will be no churn and there will be yes for the churn, and the y-axis is customer service calls, right? So the customer call means customer service call. So it is showing the customer service number of customer service calls. So when the customers are not churning, all the values are below 3, but there are only 5 values above 4. So as compared to 3 and 4, means as compared to highest value 4, that must it will be considered as a higher value. So these 5 values are out of this whisker. So these will be called as outliers. As well as when the churn is S, then there is only one outlier. Now you see there is again difference, that when the churn is no, there is a minimum value, there is first quartile, there is second quartile, and the maximum value. There isn't any median, right? So when it happens, when your median is very near to any of your quartiles, then these things happen when there is the median range or the median value, or say the Q2 value is not shown. But as compared to yes, there is all the 5 numbers, mean there is a minimum value, first quartile, second quartile, third quartile, and the maximum value. All 5 values are present, right? So this was for the box plot. So guys, this was for the types of graphs and types of charts and the data visualization part. So thank you for watching the video.